All right, so moving along with our theoretical development and getting used to the concepts and consequences of having to think in terms of several velocities, let's consider the case where as the outlaws escape in their getaway car, which goes at 3/4 the speed of light, the police officer fires a bullet from the pursuit car, which only goes half the speed of light. The muzzle velocity of the bullet relative to the gun is 1/3 the speed of light. Does the bullet reach the target? And now we have to consider the two cases of A, according to Galileo, and B, according to Einstein. Fair enough. And what we see here is that we have the cop car traveling at half the speed of light, the gun shooting a bullet or projectile at 1/3 the speed of light. But this guy over here, they're traveling at 3/4 the speed of light. So pretty cool. All right, how do we tackle this? Well, of course, what we know we need is the Galileo velocity rule and the Einstein velocity rule. We saw this the last couple questions, so we'll just go ahead and move on through. How do we solve it? Well, let's consider that in general, we need to know the velocity of the bullet in order to compare it to the velocity of the getaway car. Clearly, if the bullet's velocity is greater than the getaway car, in the first case, we get the bad guys, so the bullet does reach the target. If the velocity of the bullet is less than the velocity of the getaway car, then we don't. Pretty simple. So let's go to part A and add these via Galileo's relationship. So, we were told that the cop car was traveling at 1/2 the speed of light, and the gun shoots off its bullet with a muzzle velocity of 1/3 the speed of light. Add these two together, straight add, we see that we end up with 5/6c. But in order to compare the two velocities of the getaway car and the bullet, we need to find a common denominator to compare the fractions. Here, that common denominator is 12 and 12. But in doing so, what we see is that 10 is greater than 9, but 9/12 is equal to 3/4, 3/4c, and that's the speed of the getaway car. So since the speed of the bullet we just found is greater than the speed of the getaway car, the bullet does reach the target. That's pretty cool. Check mark there. Now, if we compare the bullet relative to the ground using the Einstein rule, what we see is that we have V bullet with the 1/2 plus 1/3 in the top, the 1/2 times 1/3 in the bottom. Note here that the C's canceled. We showed that a couple times already, but just know that it wasn't a typo. They are meant to be like this. We see here that we end up with a fraction over a fraction, multiplied by the reciprocals. We see that we're multiplied by the reciprocal of the denominator. We see that the 6's cancel, so we're left with a 5/7c. Again, let's find a common denominator. Common between 7 and 4 is 28. So let's get everything to the appropriateness. And we see that we end up with 20/28c for the bullet using the Einstein rule. And we see that we end up with 21/28 for the getaway car in the conversion factor. And so we see that 20 is less than 21. And so the velocity of the bullet under Einstein's rule is less than the velocity of the getaway car, so the bullet does not reach the target. So as you see, using the appropriate rule for the appropriate velocities does matter. And in fact, we'll see more of this very soon. But other than that, pretty easy question, I would say.